The hydrogen economy, what we need to know and why testing and standards matter. It was interesting to hear the National Infrastructure Experts discussion panel to begin today's sessions. The discussion relating to the use of alternative energy sources for energy or electricity generation in our collective attempts to address or mitigate the effects of climate change. One important aspect of new energy sources that is emerging and being expanded is, of course, the use of hydrogen extensively, not just for energy or electricity generation, but other applications as well. And with the introduction of new technologies, it of course brings in challenges to ensure the safe implementation, operation, and equitable commerce in the use of that energy source. So with that, I'm pleased to introduce this afternoon's speakers, George Sfinas, Engagement Manager of Standards Australia, and Wodek Jakubik, Innovation Manager at Coregas. George's presentation, Standards Building, the Pathway to Hydrogen Accreditation, will discuss the role standards play in ensuring quality, risk mitigation, and global recognition throughout the hydrogen supply chain. While Wodek, who will begin presentation, will include some background on the new measurement technologies, issues and challenges presented in the use of hydrogen as an energy source for various known applications in the context of where did that hydrogen come from, whether it's from the byproduct of industrial activities or it's what we could call clean hydrogen, I believe, from electrolysis. And I would also like to note, if I may, NATA's role through the accreditation of such new technologies. We find ourselves being a conduit between the new standards and their specifications and the implementation of these standards by the conformity assessment bodies such as Coregas. We note during the assessments any technical issues that are in implementing these specifications, and often it becomes apparent, those issues become apparent and addressed simply through the accreditation process and services we provide. So with that, I might begin with introducing, I believe, George is starting off today's discussion. Thank you.
Thank you, Paul, and good afternoon, everyone. My name is George Sfinas from Standards Australia. I'm in the electricity and gas sectors, so gas, of course, very relevant to the hydrogen presentation today. And I will be talking about building the pathway to hydrogen accreditation, but before I do that, I think it might be good to provide some context on who we are. I'm sure some of you would have heard our Chief Operating Officer, Corrine Riley-Tarkos, earlier this morning, but just to recap, we are Australia's peak non-government, independent, not-for-profit standards body. We celebrated our centenary in 2022, so we've got over 100 years of experience in standards development. We represent Australia on the world stage. We're Australia's members to the International Organisation for Standardisation and the International Electrotechnical Commission. I'll refer to them as ISO and the IEC going forward. And we've also got a memorandum of understanding with the Australian government, and we work as a trusted partner to government and industry. I just need to use the clicker. Our focus is primarily on standards development, but we also do publish other lower consensus documents such as technical specifications and handbooks, and some of them are quite relevant to the hydrogen space, so I will highlight a few examples shortly. So what is a standard? A standard is a documented agreement that provides guidelines and specifications used to ensure the consistency, quality, compatibility and safety of products and services. Essentially, they keep people safe and they ensure things work as they are intended to. As mentioned, standards are voluntary documents, although I will have some information on that in the next slide. and they are consensus-based documents. Our technical committees are comprised of organisations from a broad variety of Australian industry, and we work to ensure that the standards are consensus documents. Standards are published by Standards Australia, but they're not written by people like myself. I'm just a facilitator. They're written by stakeholders who are technical experts in their particular area. So I guess you can read this thermometer as we're talking about the level of government intervention. On the left there's no action whatsoever, and on the right-hand side there is physical regulation or legislation. And standards sit somewhere in between that, as you can see on the graphic. They're a cost-effective and streamlined alternative to government regulation, and I will touch on that with the high standards tool I talk about in the collaboration between Standards Australia and the CSIRO. But standards can also be caught up in regulation, and I think a perfect example of standards being caught up in regulation is the National Construction Code. For those who are unfamiliar, the National Construction Code is the building and the plumbing codes of Australia. And in the National Construction Code, we've got over 200 reference standards, the majority of them Australian standards and some international standards as well. And this is a perfect example of co-regulation where standards are actually embedded in regulation. So why are standards important? And apologies, I'm not sure why that graphic has turned out the way it has, but I guess the first reason is safety. So standards establish safety protocols for the production, the usage, the transportation and the storage of hydrogen. And they ensure the protection of personnel, infrastructure and the environment. Standards are also important when it comes to quality assurance, so they define specifications for things like hydrogen purity and hydrogen performance. So this enables a reliable Australian hydrogen sector. International alignment, and you'll hear me talking about international alignment a fair bit, but it ensures compatibility with the global supply chain and facilitates trade with our major trading partners. And finally, market confidence. Standards instill confidence in investors, consumers and regulators, and by adhering to established standards, the hydrogen industry can build that robust and trustworthy market. So looking at the state of play with hydrogen standards in Australia and what we're doing at Standards Australia. So ME93 serves as Australia's National Technical Committee on Hydrogen Technologies. All standards we've got in the hydrogen area have been discussed and ratified by all the experts on this committee on ME93. And as you can see on the graphic there, ME93 has broad representation from across industry. We've got technical associations, auditing bodies, gas regulators, gas suppliers, academia, even the federal government are represented on ME93. Now, ME93 also serve as a mirror committee to the International Committee for Hydrogen Technologies. This is facilitated by ISO. And this means that ME93 serve two unique roles as that mirror committee. The first role is that ME93, the experts on ME93 travel internationally. They represent Australia at the International Standards Development Table, and they actually sit at the table while the international standards are being developed and drafted. And this is a segue to the second role, which is that once those international standards are developed, ME93 then are expected or review the standards to then adopt the standards in Australia. And you will see, and there'll be a slide coming up which shows the hydrogen standards we've adopted and developed so far, and you'll see the overwhelming majority of standards in our portfolio of those that are adopted. Not an issue. We're Standards Australia are huge supporters of international alignment and international standards development. And just to clarify, because I suspect some might ask, if we've got the ISO standards, we've got international standards that have been developed fairly rigorously, why do we then need to go and adopt them and make them Australian standards? It's a good question, but I guess the answer to that is that we've got an international standard that's been developed by a diverse range of countries and regions, and even though it's been developed at the international table, it's been developed by a broad group of stakeholders, by formal ratification of our technical committee, and if our technical committee and our experts have actually reviewed the standard and they agree that it's fit for purpose for use in Australia, we can then adopt it and it becomes an Australian standard, as much of an Australian standard as a standard that we've developed from scratch. So that's why we're huge supporters of international alignment. Now, last month, and this is quite hot off the press, ME93 published their work program, and the purpose of this work program is to identify and set priority areas in hydrogen standards development over the next few years. In scope include things like hydrogen fuel quality, hydrogen storage, hydrogen for use in pipelines, hydrogen for use in fuel cells and vehicles. Out of scope are areas like carbon capture and storage, ammonia, other synthetic fuels, and the reason for this is that a lot of that work is actually being done in other committees. So if you haven't already scanned the QR code, please do scan that QR code on screen. That'll take you to our website where you can actually access ME93's work program. This here, and I apologise, there's a fair bit going on this slide, but this is just a snapshot of the standards ME93 have adopted and published to date. I won't go through all the standards, but some of the key ones. AS62282 is that series is the IEC series focusing on fuel cell technologies, and we've adopted this series. We've got the AS19880 series, which looks at gaseous hydrogen fueling stations, and that was adopted by ISO. Other ones include AS ISO 14687, which specifies the quality of hydrogen fuel for vehicles. And I want to just focus on one of our own specifications, so something we haven't adopted from ISO. You'll see it under storage there. It's Standards Australia Technical Specification 5359. And apologies, I hate talking in standard designations and codes, but that is the way our standards, I guess, referenced. The title is The Storage and Handling of Hydrogen. Standards Australia published this document late in 2022, and it was Australia's first national hydrogen specification, and at the time it was also the world's first standalone document on the storage and handling of hydrogen. So a major achievement for Standards Australia, but also a major achievement for the Australian hydrogen sector. And I think even in the international standards landscape, this really put Australia on the map. There are some other critical standards being developed internationally, and I'd like to point your attention to this technical specification, 19870, which looks at the methodology for determining the greenhouse gas emissions associated with the production, conditioning, and transport of hydrogen to consumption. This is in line with ISO 1467 and the other ISO 1400 series you can see there on the bottom of the slide. And why this is important is because it dovetails quite nicely into the proposed or the Guarantee of Origin scheme, which is being designed by the federal government, which will provide a mechanism to track and verify emissions associated with hydrogen. So yet again, a perfect example of how standards can support proposed schemes and regulations. The High Standards tool. So I'll just spend a few minutes talking about this tool, and this tool could not be possible without the collaboration of both Standards Australia and the CSIRO. This is a central point of guidance for hydrogen standards in Australia, and it is a fairly comprehensive standards reference, and I will have a graphic in a minute which just shows the breadth of standards we've collated for this. The tool itself is actually hosted in CSIRO's Hydrogen Knowledge Centre, which was established by the CSIRO in 2021. And this knowledge centre informs and develops a fairly robust hydrogen sort of think tank here in Australia, and this tool will only add to that. With the High Standards tool, we've gone for 5 scenarios, and these are the 5 scenarios that are most relevant to the Australian context. So we've got the electrolyser production of hydrogen, we've got hydrogen pipeline transportation, road transportation of hydrogen, hydrogen blending, and then refuelling. As you can see there, here are in collaboration with CSIRO, here are some of the standards or the areas of the standards we've collected. it's a fairly broad standards mapping exercise, and some of the standards here include Australian standards, joint Australian-New Zealand standards, international standards such as the ISO and IEC standards I've been referencing. We've also got some North American standards and some European standards as well. And I guess this just talks to the importance of aligning ourselves internationally with other international standards, because the majority of the standards that are currently out there are actually international standards themselves. So I'll just talk you through some of the key scenarios in this high standards tool. So the first one is the electrolyser scenario. As you can see, we've got the electrolyser itself, and we've got those two blue icons you can see just on the electrolyser, and these identify some of the electrolyser standards that exist, but also some of the fire safety standards for electronic elements. From the electrolyser, the hydrogen then is transferred, it undergoes compression and cooling, and we've got the relevant standards there. And finally, the hydrogen itself needs to be stored, and we've got relevant gas and hydrogen storage standards from those standards we've mapped. Moving to the blending or the hydrogen blended scenario, you can see the hydrogen and natural gas being blended and then separated. It then undergoes compression and cooling. So obviously with the different scenarios, we add and take away different standards depending on their relevance to the different scenario. And the last scenario just focuses on hydrogen refuelling stations. So here you can see there's a focus on storage initially. We then go again to compression and cooling, and then there's some refuelling standards. And I guess I'd also like to just zoom in on the refuelling of the scenario there. We've got standards that look at some of the valves. We've got some hydrogen car interface standards we've mapped, fuel quality standards, and some other standards that look at things like hydrogen vehicle fueling stations, standards specific to those stations. So this is the high standards tool in a nutshell. It is important to note that this is a first iteration of the tool. The tool will be updated as the sector evolves, as more standards are developed and adopted both nationally and internationally. We will see updates, and we will constantly update the tool to make it relevant and fit for purpose. So just as I conclude, I'll have the QR code there on the screen so you can actually access the high standards tool. But adopting and developing standards in Australia is not only essential for safety and quality, but it's also a strategic move to build confidence, to drive innovation and position Australia as a global leader in the hydrogen market. And as I've discussed over the past 10 or so minutes, standards provide the necessary framework for a sustainable and prosperous hydrogen future, and they are a sure pathway to hydrogen accreditation. Thank you.
I would like to thank Nata for not putting me last on the second day. Usually when I'm talking in the afternoon on the last day, I have half of the audience. To be honest, for the first time, I'm speaking sometimes in different conferences. I never have so much spotlight. So right now I can see only first 5 rows. So what, 10 people here? So I hope there is somebody in the background listening to me right now. I will be talking about hydrogen testing accreditation, and it's a very diverse audience. When we started today, I heard about water and food. I can relate it to myself. I know I'm drinking water every day. I want to know what's the quality, how it's tested, is it accredited. When it's coming to hydrogen, it's difficult. You can't see it. You can't smell it. You probably heard that it's flammable, so you're running away from that. So that's what it is. So I have 2 parts of my presentation today. First is about hydrogen economy. I don't know about your Google search, but when I'm switching on my computer, I can see 50 messages, 60 internet articles about what's happening in the hydrogen, how great Australia is doing. We are leading the world, okay? And then on the other hand, I'm looking what's happening around, I'm thinking, really? Is it really happening? So I will talk a little bit about hydrogen, but let's start from hydrogen facts. Okay, look back to the high school. So as I mentioned, hydrogen is flammable, colorless, it's the lightest gas. It contains proton and electron, it's the simplest element in the universe. And what is kind of, let's say, interesting, it's more than 70% of universe mass. Okay, I don't know, I read 70%, somebody else said 80%, somebody said almost 90%. I just wonder which laboratory tested this and how it was accredited. So that's where we are right now. Anyway, 70 is a good number. So most of the universe is built from hydrogen. Second fact, abundant energy. It's a result of hydrogen fusion, stars, sun. The energy we're getting from sun, it's coming from hydrogen. So thank you very much, hydrogen. Hydrogen is not new. Was, I would say, identified in the middle of 18th century by British physicist Cavendish, and we have a long history of using hydrogen almost everywhere. But now what's happening, hydrogen is present not only in the universe, it's present on Earth. It's a building block of water, propane, methane, other hydrocarbons, fat, sugar, acid, polymers, it's almost everywhere. It's a building block of everything. So that's the facts about hydrogen. So why are we suddenly talking about this? It's very mature technology, very mature industry. It's used in the huge quantities in hydrogen sulfurization. So refineries are using hydrogen to remove sulfur from the fuels. So if you want less polluting fuel coming from the car or the truck, the petrochemical companies are using hydrogen to remove sulfur. The bad news for Australia is, for the last 20 years, we are shutting down refineries. So there is less hydrogen in Australia in refineries this year that we had back 10 or 20 years ago. Ammonia production, this is one strong industry. We have a lot of ammonia production for fertilizers and explosives, for mining industry, so this industry is doing very well. Again, it's a Haber-Bosch process. It's 80 years old, nothing new here. We don't have rocket fuels, but hydrogen is used as a fuel for the rockets. Semiconductors, we used to have some semiconductor facilities. We don't have them anymore. We used to produce solar panels. We're not producing them anymore. Annealing, brazing, sintering, yes, we had it, but we closed the automotive industry. We are doing less manufacturing. However, laboratories, gas chromatographies are strong, still strong in Australia. So this is our major market. So what's new? Why we are talking about this right now? Why hydrogen rush? Okay, I think that we can agree to the one conclusion that we kind of would say after 10 years of debate, we can agree that we have a global warming and the climate is changing. So as a response, different agencies, different governments, different companies came up with idea of decarbonization, and they see hydrogen as a path to decarbonize. Not everything, but to decarbonize something. One of the key areas where we should decarbonize is electricity, and we are doing in this space very well. We are putting solar panels, we are putting wind turbines. There's only one problem: how to store it. So that's where the hydrogen is coming to play as a clean energy carrier. Okay, so if we can produce, so different group of interest have people thinking about environmental change, people are talking about energy storage, they're talking about the greener grid, energy security, or economic development. Everybody have a different point of views, but I give you just a clean example. South Australia government, electricity is owned by the state, so they decided to install a lot of solar panels, solar farms, wind farms. Now they have too much renewable electricity during a day. And sometimes they had to cut the roofs of the houses from the grid because too much electricity is not good. The grid is not unbalanced. So now they came with idea of spending $600 million on building 215 megawatt electrolyzer, 200 megawatt power plant, and big pipeline to store hydrogen. So when there's plenty of electricity coming from the solar and wind, the electrolyzer will be working, producing hydrogen to the pipe, and when the sun is coming down, the gas from the pipe will come and power the plant to produce electricity during a day. Good luck. That's a very ambitious project, and I think that this is an example how the energy, hydrogen can be used as energy storage and make the grid greener. And of course, economy, everybody's talking about jobs, jobs, jobs. So that's one of the key area when the government is looking at hydrogen as a silver bullet solution for every problem we have. State of hydrogen. Okay, I don't know if you heard about this, but it was $2 billion allocated in last year's budget for hydrogen economy. ARENA is managing that as a Head Start program. They got another 1.3 billion this year, another 1.7 coming in the future Made in Australia. Hydrogen is part of it. And on the top of it, for whoever can produce green hydrogen can get from government $2 per kilogram until 2040. So guys, start making green hydrogen. I don't want to mention it today because I will be talking about testing of hydrogen, but I want to come up here with another accreditation issue or challenge. If we are talking about green, we love the word green. It's probably one of the most abused or used word right now. Everybody loves green. Our trading partners, they are going away from the word green. They want to know what is the carbon intensity of the product they're buying from us. Is it hydrogen or green ammonia, whatever. They want to know how many kilograms of carbon dioxide or equivalent gases have been emitted during hydrogen production or ammonia production. And that's where we are. The Australian government and a few different agencies are working on something which is called guarantee of origin, which is a very complex process. And I hope that maybe we can have a discussion later on about this, how to guarantee that something is green. And I give you just a simple example, and I will finish this guarantee of origin at this point is, if you bought Tesla back 5 years ago, because it's a prestige car and it's green, that's great, congratulations. By the way, I'm driving electric car myself right now. But if you bought a Tesla 5 years ago and you were driving during the day and you came home and plug in your Tesla to the grid, your emission was higher than a diesel or petrol car. Why? Because the grid in New South Wales, Victoria, Queensland, and even Australia at the time was mainly fossil fuel, and the carbon emission to produce electricity coming to you were much higher than emission from diesel or petrol. But people thought, I'm driving a green car, zero emission car. Yes, at point of use, nothing is coming out. But production process is not very, very, very green. That's why Japanese, Koreans, and even government asking us, okay, prove how much emission is in the whole process of producing hydrogen. How we are doing? We are doing extremely well. We can congratulate ourselves. The carbon dioxide emission are dropping significantly over the last 20 years. We have an even great success around 2020. That was a COVID year. So we were driving less and we were moving less. On the right side, you can see the pie. This is where the emission coming from. I already mentioned electrification. This is the biggest chunk of our emissions. I will move now towards testing, and I want to show here that almost 20% of our emissions are coming from transport. And how we are doing in transport space. Okay, it's growing. Forget about the COVID time. It's growing, it's getting bigger and bigger. And you have on the chart on the right side, passenger cars are doing well. This is based on the petrol, okay? So it's slowly coming down. Cars are more efficient, cleaner, and on the top of it, it's an uptake of electrical cars. Where we are not doing very well is heavy transport. This is a diesel consumption. You see here, we have a significant growth. So what can we do? How we change the situation? And this is, drums please. We have vehicles which are powered by hydrogen. We are calling them fuel cell electrical vehicles. And this is comparison, the benefits, cons and pros for different vehicles. As you see here, those vehicles are, I would say, much better when it's coming to emission in comparison with diesel. And they have much better refueling time and better payload than battery electric cars. So they are not really very good for, I would say, passenger cars, because that's where the volumes are coming. But when you have a vehicle which is working many, many hours every day, or has to carry heavy load, like, I don't know, truck going from Sydney to Melbourne, then the payload and hydrogen plays important role. Okay, and this is how the truck look like, okay? So this is really electric truck, has a battery and electric motor, but battery is relatively small because all the electricity, most of electricity is generated from the fuel cell, from the hydrogen and the fuel cell on board. So you have as powerful truck as diesel, and you can refuel it in 5 to 10 minutes, depending on how much hydrogen do you need. And by the way, we have few already in Australia. That's a good news. Okay, what we are doing as a Coregas, we are supporting this hydrogen momentum. We have to say we are a bit crazy. My boss is asking me why I'm wasting all this time talking about hydrogen, but I don't know how many of you know that this is a very little picture in the top right corner. This is Opel Zafira. That was a hydrogen car. We had it in Sydney during Sydney Olympics. So 24 years ago, we had a hydrogen car in Australia. After Olympics, it was parked and sent back to Germany. By the way, if we have anybody here from NMI or CSIRO, the hydrogen was liquefied at their facilities in Lindfield in year 2000. So what we've done after that, we installed hydrogen refueling system for Hyundai at North Ryde. That was the first hydrogen-powered car. Then we done funny things with, we liquefy hydrogen and we load it on the ship and send it to Japan. And now the Japanese working on the huge project, which is thinking, oh, if this shipment was successful, maybe we can produce, let's say, 700 tons of hydrogen, liquid hydrogen per day, load it on the ship and send it to Japan. Okay, the project is around $10 billion, but that will be a lot of work and a lot of economical growth in Australia. Small things, not everybody is interested. This is a big drone on the right side. This is industrial drone for flying around the mining site, farms, emergency response. It's hydrogen power. And we have a first buses running around Australia, not the first 2 buses which were in Perth 2003, 2004. Now we have few more trials with hydrogen buses. So what we've done, instead of talking about this, let's do something. So we built a refueling station in Wollongong. I invite everybody who wants to see it. Most welcome. It's inside the BlueScope site. I just have to warn you, it's not much to see. You just see dispenser. This is not magic. This is not NASA rocket going to the moon and people watching it for a week. Is going to blow. No. This is just a simple dispenser, nicely painted, orange and blue. And the guy is coming every day, refueling the garbage truck. They started in October. So the garbage truck in Wollongong is quiet because it's electric, have a zero emission, water is coming from the pipe, and it's picking up 1,200 bins every day and climbing Mount Ousley, if somebody knows this area around Wollongong. So I would say good demonstration. And now I'm asking myself, what I'm doing wrong? Why we have only 1? There are 5 under construction, but by the time they will be installed, there will be another couple of years. So why we are doing wrong? Why we can't get those things moving faster? Okay, analysis. Why we are doing analysis? This is a tricky one because this is for probably bigger audience here. Okay, we have to present product specification. We have to present the analytical results for all those industries which are showing before, ammonia production, burning something, fat hydrogenation. The quality of hydrogen was not that really important. 99.9% was fantastic. But now when we're coming to mobility, suddenly there are critical impurities we can destroy the fuel cell. So we want to compare results, and everybody else is doing that. So here, this is standard. This is Australian standard, I would say copy of international standard, ISO standard. It's changing all the time, but this is, let's say, some version here. As you see, currently we were supplying to the past product on the right side, we call it 5.0. It was 99.999 purity. Now fuel cell, so heavy vehicles required only 99.97. But in comparison what we've done in the past, 3 components we have to analyze. Now we have like 15 or 20. And some of them are extremely difficult, almost impossible to analyze, like sulfur on 4 parts per billion level. So I'm putting a reference here for high standards. You can read this, you can see references, you can get a full print of this standard. But just keep in mind, this standard is only talking about what the purity of the gas should be, or what impurities should be. However, there is another standard you should refer to, which is the standard which is talking about hydrogen quality control. Because this standard is telling you, if you are producing hydrogen using electrolysis, you don't have to worry about sulfur, because it's a very small chance, or almost impossible, that you will get a sulfur coming out of water and electrolysis. So that's why this is very important, that if you are in the space of hydrogen analysis for fuel cell application, you refer to this specific standard, which was published back a year ago, to refer to what kind of a quality control process do you need. And now coming to the last slide, this is conclusion. So I already was talking about guarantee of origin. That was the first thing I mentioned, which is kind of, let's say, outside of our scope, and we have to wait for federal government to come up with the template, the guidelines, the rules, and accreditation. And I'm sure at some point somebody will be auditing those certificates, and I'm sure that NATA will get involved. There is another thing which kind of, let's say, we are not thinking about this right now, is measurement of quantity. When you are going to the petrol station and you are looking at this digits ticking, okay, 65 liters. I said, really, 65? I thought that my capacity is only 62. How I put 65 liters in my car? Okay, accuracy of the measurement. I understand that liquid is much easier, liquid at low pressure is much easier to measure, but still every flow meter on the pump has to be sometimes calibrated by accredited lab. For hydrogen, I'm assuming it will be done as well. But the problem is, we are pumping hydrogen to the truck at 700 bar. I mentioned before, this is the lightest gas. So back a few years ago, it was impossible to get a mass flow meter which will measure it. You can't have a turbine which is turning at 700 bar. So you have to find out different methods of measuring. And those methods are coming, but you can't get the same accuracy what you can get on the petrol pump. This is not a big problem because, as I mentioned, we have 2 vehicles in Port Kembla, 2 buses in Melbourne, 2 buses going to Tasmania, 2 in Adelaide. It costs millions to have them on the road, so who cares about the error, few percent this way and that. But if it becomes a mass application and you have thousands of trucks going to the public refueling stations, they would like to know that the measurements are accurate, and I believe that somebody in this room will have to come up with solution, somebody has to come up with accreditation, and somebody will have to set up a lab which will go and calibrate and test this equipment. So conclusion, key changes are in the hydrogen fuel cell application. Don't worry, millions and millions of dollars going, or billions of dollars going for ammonia production will not require any measurement, changes in analysis. Continuous changes in the standards and requirements. Quality control is extremely important for fuel cell application because it can damage the fuel cell of the truck. If it's one truck, no problem, but if you have a fleet of 100 buses running on hydrogen and one day they are filling the tank with contaminated hydrogen and the whole fleet is stuck, then it's a big problem for the city. So not quality, 99.97. This is not important, but critical impurities, which can damage the cell. Transport demonstration in multiple locations about Australia right now. Very expensive, some of them are not practical, but this is how we are doing things. As a matter of fact, this is maybe interesting. Australian company, Transit Systems, is running hydrogen buses in London for the last 15 years. And they can't run buses here in Australia. They won't, but state government has to fund the buses. We personally believe that the model back to base is much easier than highway because you don't need a public refueling station, you're refueling yourself and your depot. And what is very important, and we are engaging everybody we can, that successful trials are critical for further development. If there are any failures, any accident, any incidents, anything happen, a lot of people will say, oh, we told you it's not going to work. So thank you very much for your time. We have a few minutes left for question.
I do have 3 questions, and I might direct this more towards Wodek, but George, please participate if you can. And it's relating to the safety of use of hydrogen in vehicles. So to sum up the questions, what if the vehicle has an accident? Is hydrogen safe?
Okay. The first hydrogen cars, not trucks, but hydrogen cars, were built by very reputable companies, Toyota, Hyundai, BMW, and those companies will not take a risk to put a product on the market which can damage their reputation. So, of course, everybody knows about some Hindenburg accidents, and hydrogen will burn, will explode. So there was so many technical solutions, so much development and design done into building hydrogen car that they done in Europe drop test. They took a car and they drop it from the certain heights. They were using the bullets, the gun, to shoot through the cylinder with hydrogen at 700 bar. Nothing happened. Those cars got the highest safety rating. And of course, they have a technical solution, a technical protection, that if something is happening, the systems are working. They are hydrogen sensor, they are shut-off valves, non-return valves. So I was driving this car many times. We have hydrogen trucks and buses coming to our facilities. We have absolutely no concern, no problem from the safety perspective. Of course, we have to follow the regulation standards and rules, but we have more protection, more detector, more sensor on our hydrogen plant than any other part of our business. So this is the most tested and monitor session. Again, the risk and failure of hydrogen right now can probably derail the hydrogen for mobility very quickly. That's why everybody is extremely careful.
Thank you. And just I combined 2 questions for George. And it's good to hear. It relates to what training is available for technical experts to work effectively on standardisations, and how do I become a member of one of these standards teams?
Yeah, it's a great question, and actually as I left the lectern I thought I didn't include any information about participation. Hydrogen is a little bit of a funny area at standards. We've kept the technical committee relatively small and nimble and agile as it can be. It's quite tough. It is quite an area where a lot of people have wanted to join the committee. So we have kept it small, but we've got a great, we call it the Hydrogen Forum. It is a forum for members of the public to get involved, and they can hear, I guess, first-hand updates of where the committee, or the committee's activity, what standards we've published, standards we're looking at adopting. So if anyone does have, or if anyone is interested in joining that Hydrogen Forum, I definitely recommend it as a great avenue to receive some of these standards updates. So happy to have an offline conversation with anyone. With regards to training, we have a great academy resource where we do have many great training resources relating to things like how to write or how to draft an Australian standard and other areas, but we are also looking at doing interactive training videos to actually get out to the public. We're doing one with artificial intelligence, and I'm sure there's scope for us to do something similar in hydrogen.
That's good to hear. Thank you, George. And just one more question, if I may.
I would just to add, just keep in mind what I said at the beginning. Hydrogen is the lightest gas. So if it's leaking, it's going straight to the air and dispersed in the universe, so you don't have to worry. Like LPG cylinders is heavy, and then you can have a concentration and explode. But when it's coming training, this is on one hand success story, and the other kind of confusion. Pretty much every state wants to create a training material. So you have a different level of TAFE trainings for tradies on different level. In New South Wales, it's a very basic, it's really for the drivers of hydrogen vehicles, it's for the students, it's for the people which are coming and refueling. It's called Hydrogen Fundamentals, First Response. That's available from the New South Wales TAFE, but every TAFE around Australia is working on something. Queensland got micro-credential for the fitters, for the tradies. And there are now a lot of universities are working on the training material as well. So depending which state you are in, please Google or come to us. We'll give you the list of, I would say, probably 50 different courses, trainings around Australia in the hydrogen space. This is probably one of the most trained area other than cyberspace and AI.
Yeah, that's right. There's a lot of training that goes beyond the realms of standards. So yeah, that was quite important to note.
Yeah, thank you. And one last question for me, and I have to bring it back to a national perspective. And Walter Wodek and the great work that you do, Coregas is one of our accredited facilities as a certified reference material producer. But with regards to those activities and the reference gases you produce, the mixes, how important do you find accreditation and the recognition provided in international trade of your certified references?
Okay, I was earlier today at the session by Graham Drake. He was talking in another room about accreditation, and he said something very, very interesting. He said, look, test results without accreditation, this is just a piece of a paper. It could be good, it could be bad, but can you trust? Okay, depends. If you like the guy, yes, you can trust. If you don't like him, okay, that's a problem. So accreditation is extremely important because it's giving you, I would say, certainty that the results, you can trust the results produced by the lab. And it, as he mentioned, has to be impartial, has to be, I would say, reliable, and that's pretty much what it is. So accreditation is extremely important, especially in this space. It could be accreditation for third party, but it could be accreditation for even in-house analysis if you want to, I would say, use it for somebody else.
Thank you, Wodek. Thank you, George.